Hello everyone. In the last video we have seen two methods for your inverse transform technique. Okay. Today we'll see the third method, that is weibull distribution. See here in this weibull distribution the PDF is given. What do you mean by PDF? It is the probability density function. Okay, for each and everything PDF and CDF will be given, but in order to prove the things we will take only the CDF. Okay, that is your continuous distribution function, not the probability distribution function or the density function. See, this is the probability density function for the weibull distribution they have given. F of x is equals to beta divided by alpha power beta, x power beta minus 1, then e power minus x by alpha whole power beta. When x is greater than or equal to 0, then it is 0 otherwise. Okay, I have just told you have to take the continuous distribution function. The continuous distribution function is given as 1 minus e power minus x by alpha whole power beta. Okay, let us see the procedure for this one. See, this is the step 1. It is CDF is given and I'll just assign this continuous distribution function to f of x. Okay, that is f of x is equals to the equation. Then what is the next step? As we know, you have to just set f of x is equals to r. Okay, then now this one f of x is equals to this one and this will be equal to r. That is, I'll just write it as r is equals to 1 minus e power minus x by alpha whole power beta. Now what you have to do, you have to solve for x. In step 3, what you have to do, you have to get x is equals to f inverse of r. Here I have f of x is equals to r. If you have to solve for x, you have to write x is equals to f inverse of r. See here, just I will take from this, I know 1 minus e power minus x by alpha whole power beta is equals to r. You have to solve for what? X. I'll take this r this side and e this side. E power minus alpha by x by alpha whole power beta is equals to 1 minus r. If you have any exponential function to solve for x, you have to take the logarithmic function. So taking log on both the sides, you will get log e power this x by alpha whole power beta is equals to ln of 1 minus r. Always if you are taking for the log for this exponential function, the base itself is also e. Log e to base e we will take. So this one log e to base e means if log a power n to base a means you can just write it as n into log a to base a. In the same way, I'm just writing it as minus alpha x by alpha whole power beta log e to base e. This ln of 1 minus r I'll keep as it is. You know log e to base t is always 1. If it is having a same thing, then it is 1 minus x power beta divided by alpha power beta. I am just substituting for both separately is equals to ln of 1 minus r. Then I am taking this alpha this side. X power beta is equals to alpha power beta minus ln of 1 minus r. This complete because it should be a positive value. So I am taking the minus, that is the negative this side. Okay, I am taking x this side and ln this side. So it will become positive and it will become negative. So I am just writing it like this. Then this beta I can write it as 1 divided by beta, that is x is equals to alpha into minus ln of 1 minus r whole power 1 divided by beta. This is your weibull distribution. Using this formula only, you have to just find out the random variates. Problem, this is same as the previous section. So random numbers will be given. If you want to find out the random variate, so xi is equals to alpha into minus ln of 1 minus r I whole power 1 divided by beta. Here alpha and beta value will be given. R is your random number which is given, and the value what you get for this is the xi, that is the random variable. Okay, alpha and beta values will be given, so you can just solve it easily. And the next technique, it is very important, that is your triangular distribution. Okay, see here this triangular distribution we have in the same way. We have a PDF, that is probability density function. x, if 0 less than equal to x less than equal to 1, then 2 minus x, then 0 otherwise. This is the CDF, that is the continuous distribution function which is given. This is the main thing we have to remember, and we have to take this in order to solve the formula for triangular distribution. It is very, very important. Yes, 0, x less than equal to 0, I'll just leave this one, and 1 if x greater than 2, I'll leave this one also, because these two values are direct. In order to find out the formula, I'll take these two continuous distributions, that is x square by 2 if x is less than 0 and less than 1, then 1 minus 2 minus x whole square divided by 2. Let us start with the solution for this triangular distribution. See, what is the step 2? You have to just assign f of x is equals to r. First, I have just told you we have two things, x square by 2 and 1 minus 2 minus x whole square divided by 2. For these two things, we have to find out the formula. First, I'll consider f of x as x square by 2. Then, again, I'll consider f of x is equals to 1 minus 2 minus x whole square divided by 2. Okay. Yes. See here, f of x is equals to r. So I'll take two things here. Two continuous distribution functions are there. So I'll take first f of x is equals to x square by 2. Then f of x is equals to 1 minus 2 minus x whole square divided by 2. Okay. Next step 3, what you have to do? You have to solve for x. That is, x is equals to f inverse of r. Solve for x in terms of r. First I'll solve this one. R is equals to x square by 2. So x square is equals to 2r and x is equals to square root of 2r. This is one formula we got. And for 1 less than equal to x less than equal to 2, I'll take the second continuous distribution function. That is, r is equals to 1 minus 2 minus x whole square divided by 2. I'll just take 2 here, LCM. R is equals to 2 minus x whole square divided by 2. Then I'll keep this 2 minus x whole square here this side, and I'll take r this side. This 2r you will get. So 2 minus x whole square is equals to 2 minus 2r. This square I'll make it as square root here. 2 minus x is equals to square root of 2 minus 2r. Then x, I'll take this side, this one I'll take this side, that is x is equals to 2 minus square root of, this one I'll write it as 2 into 1 minus r. So now you have to combine 1 and 2. I'll just consider this as equation 1 and I'll consider this as equation 2. Now on combining, here you have to remember, with respect to x, if you take it as 0 to 1 and 1 to 2. With respect to random numbers, that is r, I'm taking means it is always a fraction part. From 0 to 1 we will take. In the first class itself I have mentioned, random numbers always lies between the 0 and 1. So here you have to take it as 0 to 0.5 and 0.5 to 1. Combining 1 and 2, you will get x is equals to square root of 2r here, 1, and then 2 minus 2 into 1 minus r. This is the thing. Here, how you need to solve the problem in this means, see, for example, if the random number is 0.323, then you have to apply this formula to find out the random variable. If, for example, the random number is 0.633, then this is greater than 0.5 and this is within 1, then you have to apply this formula to find out the random variate. The depends on the value of your random number. If your random number is in between 0 to 0.5, then you have to use this formula. If the random number is between 0.5 to 1, then you have to use this formula in order to find out the random variate. Okay, this is your fourth technique, that is triangular distribution. It is very, very, very important. These steps are very important in this one. And the next one is your fifth one, that is empirical continuous distribution. First, what do you mean by this empirical continuous distribution? For example, theoretically, if it is not possible to solve any of the problem, then we have to use this empirical continuous distribution. Okay, first we'll see the steps which is involved in empirical continuous distribution. And here always this empirical continuous distribution will be based on the graph or the slope. Okay, yes, see, first collect the empirical data and group them accordingly. Here, what do you mean by group them accordingly? The empirical data will be given in the problem. For the given data, what you have to do, you have to just group them in increasing order. First the lowest number should come and then it has to go increasingly. In increasing order you have to arrange all the things. Then tabulate the cumulative frequency and frequency. In chi-square test we have done the cumulative frequency. Here also you have to first calculate the cumulative frequency and the frequency of this empirical data. Now you have to just assume the value of cumulative frequency is a function of empirical data. That is, you have to just set f of x is equals to r. And then you have to establish a relation between x and r using linear interpolation. Already I have just told you. What do you mean by this linear interpolation? Linear interpolation is nothing but it is estimating a new value by connecting two adjacent known values with a straight line. See, for example, I'll be just having a graph like this. Okay, I'll be having some values over here and I'll be having some values over here. See, for example, it is estimating a new value by connecting two adjacent known values with a straight line. See, this is one known value and this is one known value. We are connecting these two known values. Okay, this is called as the linear interpolation. Here I'll get a slope. This is called as your linear interpolation. Okay, two values are known. With this one you have to just find out the straight line. That's it. Okay, so that is x is equals to f inverse of r. And then this is the value. I'll get x is equals to, this is the standard formula for your empirical distribution function. Sorry, x is equals to xi minus 1 plus ai of r minus I minus 1 by n. Okay, here why I am taking x and xi minus 1? X is here random variable. This is the first random variable and this is the previous random variable, because here slope means you have to just take the range. It is from 0 to 1 or 0.5 to 1 or 1 to 2 like that. So this is the current random variable and this is the previous random variable what you have to take, and r is as usual, it is the random number, and n is the number of empirical values. Then I have just told you it is with respect to the slope. This is how we'll calculate the slope using this formula. That is ai is equals to xi minus 1 divided by I by n minus I minus 1 by n. And then this one I'll just write it as ai is equals to xi minus 1 as it is. This one I'll solve. You will get it as I minus I plus 1. I minus I and plus I will get cancelled, plus 1 by n will be remaining. ai is equals to xi minus 1 divided by n. Okay. In the next video, I'll just show you the problem, how you have to solve this empirical continuous distribution function. Thank you.